Okay, in this video lecture, we're going to study about quotient tool. We'll give the statement and then do some examples on the same. So if u and v are differentiable functions of x, or are u and v are differentiable at x, and if v of x is not 0, then the quotient u over v is also differentiable and is given by dx of u over v is given by u prime v minus v prime u over v squared, where u prime means du dx and v prime means dv dx, and then v is not 0 as given. So first example, evaluate dy dx given y is 5x minus 2 over x squared plus 1. So solution. So you let u is the numerator and v is usually the denominator. So u prime, when you differentiate by power rule, this one you get 5. V prime, when you differentiate this one, you get 2x. So you say dy dx will be given by u prime v minus v prime u over v squared. On replacement, you'll have 5 times x squared plus 1 minus 2x into 5x minus 2 divided by x squared plus 1. So let's open. So we have dy dx will be 5x squared plus 5 minus 10x squared minus is plus 4x over x squared plus 1 square. So this will give us dy dx. This and this will be minus 5. We can have 5 minus 5x squared and then plus 4x over x squared plus 1 square. Or we can just rearrange it as minus 5x squared plus 4x plus 5 over x squared plus 1 square. So that is what we get. And then example 2, find an equation of the tangent line to the graph of f of x given by 3 minus 1 over x over x plus 5 at the point minus 1, 1. So what you do first, you get the derivative of the function solution. So dy dx, which is the same as df dx, is u prime v minus v prime u over v squared. And so we let our u to be 3 minus 1 over x and our v to be x plus 5. So remember, this can be as well written as 3 minus x raised to power minus 1. So from this u and v, we get u prime will be x minus 2, and then v prime will just be 1. So positive because this negative sign. So dy dx will be u prime, which is 1 times v, which is x plus 5, minus v prime, which is, okay, u prime is x u prime is x raised power minus 2, and then minus v prime is 1, u is given by 3 minus 1 over x, divided by x plus 5 square. And then, so we find the derivative at the point minus 1, 1, which is the same as minus 1. So this is the x value, so raised by minus 2 into minus 1 plus 5, minus 1 into 1 minus 1 over minus 1, divided by minus 1 plus 5 square. Now, minus 1 raised by minus 2 is just 1. Minus 1 plus 5 is 4. Minus, this will be plus. So this is minus 1 into 2. Minus 1 plus 5 is 4. 4 squared is 16. So this will be 4 minus 2 over 16, which will be 2 over 16 to give us 1 over 8. So we'll have this will be given by now minus 1 plus 5, that's correct, yes. And then minus 1 plus 4 square. So this we have u prime. Our u will be given by 3 minus 1 over x, which is the same as 3 minus 1 minus x raised to minus 1. And then v will be given by x plus 5. So u prime, when you differentiate this function here, you get minus. So minus minus positive, so this minus 2. Differentiate this one, you get 1. So u prime, you get as x raised to minus 2 into x plus 5, that is v, minus v prime 1 into u, which is 3 minus 1 over x, and then divided by x plus 5, then square. So at this point here, we have, so where there's x, you put negative 1. So negative 1 raised to power minus 2, then we have negative 1 plus 5 minus 1 into, so this is 3. So this is, remember this was 3. So this was 3, and then, so 3 minus 1 over 1, so minus, that will have plus here. So therefore, this will give us, this was not correct. So we'll have, so minus 1, so this will be 1 times 4 minus 1 into 3 plus 1 is 4 over minus 1 plus, this is 4 squared. So this will be 4 minus 4 over 16, so 0 over 16. So therefore, the gradient or the slope at this point is just 0. Now, equation of a tangent is given by y minus y naught equals to m. Remember, this is our m, which is the slope, x minus x naught. So will be y minus 1 equals to m is 0, x minus, x naught is minus 1. So minus 1 is plus 1. So this will be just 0. So we'll have y minus 1 equals to 0, which means the equation will be y equals to 1. So that's the equation of the tangent at that point. And then another problem on application of quotient rule. So find dy dx, not really dy dx, so differentiate f of x equals to x over 1 plus x squared. So actually the same thing as getting dy dx. So solution. So we let u to be x and then v to be 1 plus x squared. So u prime will be 1, v prime will be 2x. So dy dx will be given by u prime v minus v prime u over v squared, which will be 1 into 1 plus x squared minus 2x into u is x over 1 plus x squared square. So this will give us dy dx 1 plus x squared minus 2x squared over 1 plus x square square. Now this will give us 1 minus x squared over 1 plus x squared squared. So that becomes the derivative of that function. And then another example, d dx, evaluate d dx of e raised power t over e raised power t plus t. So solution. So we let u to be e raised power t and then v to be e raised power t plus t. So u prime, so remember we are differentiating with respect to t, so it will be e raised power t. V prime will be e raised power t plus 1. So d, so remember this is d dt, not d dx. Variable here is t. So d dt of e raised power t over e raised power t plus t is u prime v minus v prime u over v squared, which will be e raised power t into e raised power t plus t minus e raised power t plus 1 times e raised power t over e raised power t plus t square. When you simplify, you get e raised power 2t plus t e raised power t minus e raised power 2t and then minus e raised power t over e raised power t plus t square. So clearly this term and this term cancels out, so that we have t e raised power t minus e raised power t over e raised power t plus t square, which you can just write as t minus 1 e raised power t divided by e raised power t plus t square. So that is the solution to that problem. Another example on application of quotient rule. Find the tangent line to the graph of the function f of x given by 3x squared plus x minus 2 over 4x cubed plus 1 at x equals to 1. So the first thing is to find the dy dx. So dy dx will be u prime v minus v prime u over v squared. So here we let u to be 3x squared plus x minus 2 and v to be 4x cubed plus 1. So u prime will be 6x plus 1, while v prime will be 12x squared. So replacing these values into the formula, we'll have dy dx will be u prime is 6x plus 1 times v, which is 4x cubed plus 1, minus v prime is 12x squared times u, which is 3x squared plus x minus 2, divided by v squared, 4x cubed plus 1 square. Now we want the gradient at the point x equals to 1. So this will be 6, 1 plus 1 into 4, 1 cubed plus 1 minus 12, 1 square, 3, 1 square plus 1 minus 2, and then 4 into 1 cubed plus 1, then square. So when we substitute for x equals to 1, we'll get, so the first bracket will have 7 plus 7 times 5 minus 12, 3 plus 1, that is 4 minus 2, that is 2, over 4 plus 1 is 5, then square. 7 times 5 is 35 minus 24 over 25. 35 minus 24 is 11, so therefore the dy dx at x equals to 1 will be given by 11 over 25. So then now, once you have this gradient, so this like our normal gradient, which is m, equation of tangent is y minus y through the point x naught, y naught, is y minus y naught equals to m into x minus x naught. So let's get the value of the function when x is 1. So f of 1 will be given by 3 times 1 square plus 1 minus 2 over 4, 1 cubed plus 1. So 3 plus 1, that's 4 minus 2, that is 2 over 4 plus 1, that is 5. So therefore, y naught is 2 over 5. So equation will be y minus 2 over 5 equals to 11 over 25 into x minus 1. So this will be y equals to 11 over 25, x minus 11 over 25, then plus 2 over 5. And when you add minus 11 over 25 plus 2 over 5, you get y equals to 11 over 25, x, and then minus 1 over 25. So this is the equation of the tangent. So in a similar manner, you can work out as many problems as possible applying just the same rule. So the last example, find the derivative of y given by t squared minus 1 over t cubed plus 1. So solution, you let u to be t squared minus 1 and then v to be t cubed plus 1. So that u prime will be 2t and v prime will be 3t squared. Now dy dt will be u prime v minus v prime u over v squared, which will be u prime is 2t, v is t cubed plus 1, minus v prime is 3t squared into u is t squared minus 1 over v squared will be t cubed plus 1 raised to power 2. So when you open, you get dy dt will be 2t power 4 plus 2t minus 3t power 4 plus 3t squared divided by t cubed plus 1 square. Collecting like terms, so you have dy dt equals to minus t power 4 because 2 minus 3 is minus 1 plus 3t squared plus 2t over t cubed plus 1 square. So this becomes the final solution to the derivative of the given function. So that's how we work out problems involving quotient 2. Thank you.